At this time, you are going through the Databricks Certified Associate Developer for Apache Spark 3.0 training. One of the important topic with respect to the curriculum is nothing but joining Dataframes. As part of the sectional module, we'll actually go through the details about joining Spark Dataframes. First, we'll set up datasets to perform joins. Then, we'll actually talk about overview of joins using Spark Dataframes. Then, we'll actually go to the actual join concepts. We'll be looking at how to perform inner join, outer join. We'll also see the difference between left outer join and right outer join. We'll also go to the details about full outer join. Also, we'll touch base about broadcast join. There is a concept of cross join or Cartesian product. We'll be talking about that as well. All these important topics related to joins along with functions will be covered as part of this sectional module. As part of this sectional module, we are going to the details related to joining Spark Dataframes. In this lecture, let's go ahead and set up datasets to perform joins. We'll be using these datasets as part of subsequent lectures to actually take care of tasks related to joins. That being said, we'll be creating 3 dataframes using datasets that are picked from source database, which is related to learning management system. The 3 datasets which are picked are nothing but courses, users, and course enrollments. You can see here. Using courses dataset, we have created a data frame called as courses_df. Using users, we have created data frame by name users_df. Using course enrollments, we have created a data frame by name course_enrollments_df. Also, we need to make sure we understand the relationship between these 3 tables. As part of the source system, there is no direct relationship between users and courses. If you review the columns related to users and courses, users have user ID, user first name, user last name, user email. There is no column which is related to the course in this. When it comes to courses, it have course ID, course title, course published date, is active, and last updated TS. We doesn't see any columns related to users in this data frame. That being said, first we need to identify the relationships between these entities. The entities are nothing but users and courses. Then we need to understand how the relationships are actually defined as part of the source tables. Based on that, we should be able to figure out how to perform joins once we get the requirements with respect to joins. That being said, if you think from entities is RDBMS concepts. It's not related to the tables. It's general RDBMS concepts. From the business perspective of the company which is actually running the LMS, the key entities for their business are nothing but users or students and courses. These 2 are the key entities. When it comes to relationship between these 2 entities, we have many-to-many relationship. Because one course can be sold to many users, one user can enroll for many courses, which means there is a many-to-many relationship between 2 entities. So typically, once we identify entities based upon the business requirements, we create tables based on those entities, and then we tend to define relationship between the tables. In this case, courses and users or students are entities. The relationship is nothing but many to many. One course can be sold to many users or students. One student can enroll for many courses. So we have many to many relationship between these 2 entities. When we create tables in RDBMS, we typically have a users table, a courses table. However, as there is no common column between these 2, we will not be able to define any relationship between the 2. When we have entities with many-to-many relationship, as part of the implementation within the database, we typically create a bridge table. In this case, course enrollments is nothing but a bridge table. You can see here. When it comes to course enrollments, it have 4 fields. Course enrollment ID, which is unique for course enrollments. Then user ID. User ID is related to users. Course ID is related to courses. Also, we have price paid. So there is a one-to-many relationship between users and course enrollments because one user can enroll for multiple courses. In the similar manner, there is one-to-many relationship between courses and course enrollments because one course can be sold to multiple users. When it comes to relationship between users and courses in this, it is nothing but many-to-many. If you look at course 2, there are several users enrolled for course 2. They are nothing but 10, 5, 9, so on and so forth. There are several users who have enrolled for course 2. If you look at user 7, the user 7 have enrolled for multiple courses. They are nothing but 5, 3, 5 is again repeated. It can be a bug or it can be genuine also. When it comes to tables like course enrollments, typically the tables will have enrollment date also or enrollment timestamp. Depending upon enrollment date or enrollment timestamp and other attributes, we will be able to determine whether it is a data quality issue or whether it is genuine. Don't worry too much about this at this time. Make sure you understand that users and courses have many to many relationship when it comes to business entities. When we actually implement tables for those business entities, we have created 3 tables. They are nothing but users, courses, and course enrollments. As part of users and courses, there is no direct relationship. Course enrollments acts as a bridge table to actually take care of providing the many-to-many relationship between users and courses. It is very, very important for you to have this knowledge to excel with respect to joins. Without this knowledge, you will struggle to excel with respect to joins. However, as part of the certification exams related to Spark, you will not be seeing any questions related to concepts with respect to relationships between the tables or entities. The questions will be predominantly around the APIs which are typically used to perform joins. However, to make sure to understand how to use join effectively, having idea about the relationships is very, very important. As part of this lecture, let's get an overview of joins using Spark Dataframes. As in any database technology, Spark also supports all common joins. They are nothing but inner join, left or right outer join or full outer join, cross join. When it comes to Spark Dataframes, they have a function called join. We should be able to leverage it to take care of all these joins, whether it is inner, left or right outer join or full outer join or even cross join. We need to specify join condition for inner or outer or full outer join. You can actually run this to create the required data frames so that we can explore joins. The data frames that will be created because of this notebook are nothing but courses_df, users_df, then course enrollments_df. We have already gone through the details related to these data frames in the previous lecture. As I have mentioned earlier, join is available on top of a data frame. We should be able to get help by using this approach. Courses_df is of type dataframe in this case. By saying .join, we should be able to get the help on join function related to a data frame. When it comes to join, it takes several arguments. At max, it can take 3 arguments. In case if you would like to perform join between courses and course enrollments using inner, we can actually say courses_df.join course enrollments_df. As part of join, we'll be passing course enrollments_df as first argument. Then as part of the second argument, we can have the join condition. When it comes to courses and course enrollments, the join condition should be based on course ID. We'll be seeing examples as part of subsequent lectures in this section. On top of specifying condition after specifying second data frame as part of join, we can also specify how the 2 data frames are supposed to be joined, whether they are supposed to be joined using inner, which is default, or whether they are supposed to be joined using left outer join or right outer join or full outer join. If it is cross join, then we'll not be having on, or we'll not be having condition in place of on. We'll be saying how equal to cross. It will take care of performing the cross join between the 2 data frames. We will see quite a few examples with respect to all types of joins as part of subsequent lectures in this sectional module. Don't worry too much if you could not get completely at this time. When it comes to parameters, you see the other is nothing but data frame. On, we have to specify the condition. The condition can be specified in the form of string or in the form of list or in the form of column object. Using either of the approaches, we should be able to pass the condition. As part of how, we have to pass only string. By default, it is none. If you wanted to pass a string for how, it can be inner, which is default. Actually, the default for how is inner, not none. Let me see here. Here it is saying how equal to none. Even when you pass none, internally it will be converted to inner only. On top of inner, you can also use cross. When you use cross, you will not be having condition. Also, you can use outer or full outer or full_outer. All these 4 means same only. Also, you can specify left outer, left_outer. These 3 are related to left outer join. You can also have right outer, right_outer. These 3 are related to right outer join. On top of these common ones, Spark also supports semi as well as anti-joins. That being said, let's go to the examples here. All these actually perform full outer join between 2 data frames. The first one is df, the second one is df2. In this case, it says df.join df2, which means they are trying to perform join between 2 data frames. This is nothing but join condition. Both df and df2 have a column called as name. The join condition is based on that column, which is having same name between the 2 data frames. Then the third condition is nothing but outer, which means it actually performs full outer join. When the column name is same between the two data frames, instead of specifying condition like this, we can also specify the column name in the form of string like this. If you look at the syntax, you can see that with respect to on, it can be string also. It is typically used when we have same column name between the two data frames using which we are trying to perform the join. If the column names are different, then this approach will not work. Then the third approach is you can also specify multiple conditions like this. So in this case, condition is nothing but list. If you look at the syntax here, on can be list also. So this is the example related to passing the condition as list. In this case, the join condition is based on both name and age. So you should be able to pass multiple conditions like this. It will be converted to df.name double equal to df3.name and df.age double equal to df3.age. Based on the and condition between these two, join will be performed. In this case, it says df.join of df2 comma name. As there is no third argument, this will actually result in inner join, because the default is nothing but inner join. We will understand the difference between inner and outer join when we actually perform certain tasks in the subsequent lectures in the sectional module. Also, as the column names are same between df and df3 or df4, in this case we are talking about df4, assuming df and df4 have columns name and age, assuming we are trying to perform join using those two columns, we can also pass the column names in the form of list like this. So these are the examples following different styles of syntaxes that can be used when it comes to performing the joins. Make sure you are comfortable with all different styles, because as part of the certification exam, they can actually say which one is valid, which one is not valid. Unless and until you are familiar about all different styles of syntaxes, you will not be able to answer such kind of questions. When it comes to cross join, either you can say join, and then as part of how, you should be able to specify cross. You can see here how also supports cross. If you skip the on and if you specify cross as part of how, it is nothing but cross join. Also, Spark provides a function directly on top of Dataframes to actually perform cross join. When it comes to the syntax related to cross join, it will be like this. First dataframe dot cross join, then second dataframe. It actually returns the Cartesian product. We'll understand what Cartesian product is and what are the side effects when we actually talk about cross joins as part of subsequent lectures in the sectional module. As part of this lecture, let's go to the details related to defining aliases for Spark Dataframes. We have seen once in the past. However, I would like to emphasize before we get into the tasks related to joins in subsequent lectures. We use aliases more frequently as part of joins compared to other type of operations. That being said, already we have Dataframes, courses underscore df, users underscore df, course enrollments df. When it comes to aliases, aliases can be defined on top of dataframes as well as dataframe columns. In this case, we are actually talking about aliases on Spark dataframes, not the columns that are part of Spark dataframes. When it comes to defining alias for Spark dataframes, we have a function called as alias. You should be able to see the help. It takes one argument. The argument is of type string. Whatever is passed to alias can act as alias for our original dataframe. Let's see the examples here. In this case, this logic is saying dataframe df dot alias df underscore as1. So this is the alias for df. So df can be represented like this when we actually use the column names as part of the APIs such as select. If you look at the example here, in this case, we are actually saying select of df underscore as1. So whatever is specified here, which means we are referring to column name from this data frame, which is nothing but df. This is again a variable which is created. This is not the one which is being used here. They are following the same naming convention, which can be confusing. However, keep in mind that this is what is alias. Also, when we use alias on top of data frame, if you assign it to some other object, the new object will be of type data frame only. So in this case, the actual alias for df is nothing but df underscore as1. If at all we would like to refer to columns using the data frame names, we can leverage aliases. Typically, we'll use shorthand aliases, not bigger aliases than original data frames. Let's scroll down and see realistic examples with respect to alias so that you understand what I'm talking about here. First, let's check the type when we actually say dataframe name dot alias of whatever string we want to use to give alias. In this case, it is nothing but C for courses underscore df. The return type is nothing but data frame. You can see here. So when I say a data frame dot alias, if I pass a string to it, then whatever is returned is nothing but data frame, which means we should be able to use all standard data frame APIs to perform the transformations as per the requirements. So in this case, after specifying C as alias for courses_df, if I would like to review the column names using the data frame name as part of select or any data frame API, instead of saying courses_df dot course ID, I can use shorthand alias and I should be able to take it further. This is how alias is typically used. We'll actually see in examples related to join. It will start making sense why we are going to use aliases when it comes to joins. For now, with respect to select, it doesn't make any sense, but I'm actually showing this example so that how alias is typically used as part of downstream APIs such as select after defining the alias by referring to columns using the alias that is defined on top of the original data frame. You will understand when I actually talk with more relevant examples using join in subsequent lectures. For now, just keep in mind that if you want to define alias to a data frame, you just have to say data frame name dot alias, then pass a string to it. The string will act as alias. We should be able to use that string to refer to columns as part of downstream APIs that are going to be used to actually take care of transformations on top of our data. As part of this lecture, let's go ahead and understand how to perform inner join on Spark data frames. In this case, we already have 3 data frames: courses_df, users_df, course enrollments_df. Once you run this, you'll get access to these 3 data frames. Now, when it comes to the courses, we have this data. When it comes to users, we have this data. When it comes to course enrollments, we have this data. I have gone through the details with respect to these datasets as part of earlier lectures in the sectional module. If you are not sure about these datasets, make sure you review those lectures and come back here. That being said, if you look at the help on join using one of the data frames, you can see that it takes 3 arguments. The first argument is nothing but the second data frame using which you would like to perform the join. The second argument is nothing but join condition. The third argument is nothing but how you would like to perform the join. For inner join, either you can skip this or you can say how equal to inner or inner as third argument. It will make sure that the 2 data frames are joined using inner join. When it comes to inner join between 2 data frames, it is mandatory to have condition. The condition can be passed as a string or list or column type object. I have gone through all the 3 examples as part of overview of joins. Please go through it and make sure you understand how to pass the condition in the form of string or in the form of list or in the form of column object. In this lecture, we'll predominantly see the examples in the form of string and in the form of column object. Now let's go to the details about performing the inner join. We'll be using this as an example to take care of understanding how to perform inner join. The example is nothing but getting the user details who have enrolled for the courses. To achieve this, we need to join users_df and course enrollments_df. Also, when it comes to projecting the fields after joining on top of join results, we would like to project all the fields from users_df, and also we would like to project course ID and course enrollment ID from course enrollments. Let's go to the details so that you understand about inner joins. This is the basic solution for performing inner join. However, it will project all the fields from both the data frames. First, let's go to the logic here. We have said the first data frame, which is nothing but users_df dot join. Then the second data frame, which is nothing but course enrollments_df. Then we have another argument which have a condition. In this case, the condition is based on equal operation. You can also specify join condition using non-equal operation as well. That being said, on the left side of the join condition, we have user ID from users_df, which is nothing but this data frame. Then we have user ID from course enrollments_df, which is nothing but this data frame. As both have a column with the same name, either you have to pass the condition like this, or you can also pass the condition in the form of a string by just specifying user ID. Either of the approaches will work. You can see here, we are able to see all the data from both users as well as course enrollments. Also, you can see that user ID is repeated twice because both the data frames have user ID. When it comes to user first name, user last name, user email, they are coming from users. When it comes to course enrollment ID, course ID, price paid, they are actually coming from course enrollments_df. Also, if you review the output, first we are getting the user details followed by course enrollment details. The reason is, as part of the logic, we have users_df dot join course enrollments_df. As we have users_df first, we are actually seeing user details at the beginning. If you reverse, then you will see course enrollment details first, followed by users details. Also, if you understand the relationship between users and course enrollments is child table to users. When it comes to the relationship, it is based on the user ID. User ID is common column between course enrollments and users. When you have relationship between two tables or two data frames, and if you would like to perform inner join, you can also pass the condition in the form of string like this. As long as the name of the column is same between the two data frames, and also as long as the meaning of the column is same, it should work. Sometimes we might have same column between two data frames or two datasets or two tables, but the meaning of the columns might be different. Syntactically, it will not throw any error, but the results will be incorrect. That being said, when we actually pass the common column as a string like this, if you review the output, the common column is only displayed once. You can see here. There is no user ID from course enrollments, whereas when we specify the condition like this, the user ID is repeated twice. One is from users_df, the second one is from course enrollments df. So that is one advantage by using the call name as a string when it comes to the join condition. This only works when both the data frames have a column with same name, and also the meaning should be the same. When the meaning is not same, it will not throw any errors, but you will be seeing incorrect results. It is considered as a bug. Now let's see how to get all columns from users_df and course ID as well as course enrollment ID from course enrollments. Instead of explicitly specifying individual columns from users df, we should be able to say star like this. Then we should be able to get all the columns from users, then course ID and course enrollment ID from course enrollments. You can see here I have specified the data frame name, square brackets, then column names in single quotes to get the specific columns from course enrollments. So this is how you should be able to project the data on top of data frame which is returned based on the join. You need to make sure you understand how to take care of not only projection but also other type of common transformations which we typically perform on top of data frames. That being said, we can also use this approach. We can define alias for our data frames. In this case, U is alias for users, CE is alias for course enrollments. Now I'm actually saying u.star to get all the columns from users. As course ID and course enrollment ID is only part of course enrollments df, even without specifying alias, it will work. If you want, you can also specify alias here. Now, let's say I would like to get number of courses enrolled by each user. We can actually group by user ID on top of join results, and then we should be able to invoke count. However, when it comes to user ID is common between both users as well as course enrollments. That's why it is saying reference user ID is ambiguous, because it is same between both users_df and course enrollments df. It is failing. You should be able to overcome by using this approach. Instead of specifying just user ID, you should be able to specify user ID referred by data frame name. In this case, it is nothing but users_df. We should be able to solve the problem. Also, we should be able to provide alias. You can actually use alias while referring to user ID as part of group by. Even that approach will work. Also, we have seen that in place of this condition, we can actually pass string, because we have user ID in both users_df as well as course enrollments df. The meaning of user ID is also same, and hence we should be able to specify user ID in the form of string for join condition. Let's improvise on this. In this case, I am actually removing this, then saying user ID. First, let's review the output once again. We have seen this in the past also, but let's review once again. You can see that user ID is not repeated twice. We are getting user ID only once, as we specify the condition like this. Now, let me actually say group by, then user ID, then count, and let's see if it works or not. Most likely it should work, but we'll confirm. So let me paste here. Let me hit enter. Now let me replace u.userid with user ID. Let me remove the aliases also. I have removed this alias, and also I have removed this alias. Now let's run this. You can see the details as per the expectations. This is how you should be able to perform the joins and also perform some downstream transformations based upon the requirements. You need to understand how we can actually use different styles of syntaxes to come up with the solution. Also, you need to understand the side effects of using different styles of syntaxes. It is very, very important for you to be comfortable with all these aspects. As part of this lecture, let's go through the details related to performing outer join using left between Spark data frames. First, we need to make sure the data frames are available. I have already run this notebook, and it actually exposes 3 data frames. They are nothing but courses underscore df, users underscore df, and course underscore enrollments underscore df. If you would like to review details related to join, you should be able to use help, and you should be able to review the details before using it. This is the example based on which you will be performing tasks related to left outer join. It is nothing but to get all the user details along with course enrollment details. In case if the user have any course enrollments, we need to get course enrollment details such as course enrollment ID, course ID, etc. Also, on top of getting all the user details along with course enrollment details, if the user have any course enrollments, we need to provide users who doesn't have any course enrollments. In that scenario also, we need to get all user details. It will actually result in null values with respect to course details for those users who doesn't have any course enrollments. Once we start performing the tasks with respect to this example, you will understand what I'm talking about here. To solve this problem, we need to perform left or right outer join between users underscore df and course underscore enrollments underscore df. We will be able to come up with the solution using either left outer join or right outer join. However, when it comes to this lecture, this is related to the left outer join. As users underscore df is from parent table from the source database, and as we are going to use the left outer join for this lecture, we need to invoke join on top of users underscore df. So the syntax will be users underscore df dot join, course enrollments df will be the first argument, then join condition. Then we can actually specify left or left outer or left underscore outer to take care of left outer join between users underscore df and course enrollments df. We'll be seeing code snippet very soon. You will understand what I'm talking about here. When it comes to the fields that are supposed to be displayed, we need to display all the fields from users underscore df. When it comes to course enrollments, we would like to see only course ID and course enrollment ID. We don't need to get additional details that are there as part of course enrollments. Once again, we need to understand how to project on top of join results. We'll be seeing examples, you will understand. For this example, using these data frames, using just outer also gives same results. Even when you say just outer, it will give same results, but it is not correct to use outer because outer means full outer join. Make sure in case if the problem is related to left outer join or right outer join, you use either left or left outer or left underscore outer. When it comes to right outer join, you have to use right outer or right underscore outer. Don't use outer, it will yield incorrect results. From the certification perspective, make sure you memorize that outer means full outer join. That being said, this is the most basic example where we are using the first data frame, which is nothing but users underscore df, then dot join, then the second data frame, which is nothing but course underscore enrollments underscore df. Then we have the join condition. The join condition is column object here. Then we have left. You can see the results here. We got all the details from users, and also we got all the details from course enrollments. As explained earlier, when it comes to left outer join, left or left underscore outer or left outer without underscore are same. So in this case, instead of using left, we can also specify left underscore outer or left outer. Even this one will yield the same results. You can see that the user ID is repeated twice when we actually say just join without specifying any specific columns. Now, we can also use this approach where we should be able to pass user ID as string. As user ID is common between both users and course enrollments, and as user ID actually mean same between the two data frames, we should be able to specify user ID like this. If you say left, it will actually perform left outer join. You can see the output here. The main difference between the previous two approaches and this approach is nothing but user ID is not repeated twice. You can see here. User ID is repeated only once, but we are able to see all the user details followed by all the course enrollment details. But when it comes to the output, we would like to have only all the columns from users and then course ID and course enrollment ID from course enrollments. In case if the requirement is like that, on top of data frame which actually get us join results, we should be able to use select like this, and we should be able to project whatever fields we want. In this case, we are projecting all the fields from users underscore df. Then we are actually projecting only course ID and course enrollment ID from course enrollments df. You can see the output here with respect to course ID and course enrollment ID. For 3 of the users, you can see the null values because those users have not enrolled for any courses yet. Now we can also use the alias to come up with solution for this problem. If you end up using alias, this is how you should be able to refer to columns in users using alias. It will actually project all the fields from users. With respect to course enrollments, we are interested only in course ID and course enrollment ID. As there are no such columns as part of the users, it is optional to specify alias. You can see the results here. It have yielded the same results what we have seen before. So this is how we should be able to project the desired columns on top of data frame which contain the join results. So this contain all the fields and we are projecting only the required fields. Now let's see how to get all the users who have not enrolled for any courses. For example, in this case, the users 1, 2 and 6, they haven't enrolled for any courses. That's why we are actually seeing the course enrollment details as null values. To actually get only those users who haven't enrolled for any courses, we should be able to use filter on top of data frame which contain the join results like this. This logic returns a data frame, it contains the join results. On top of join results, we should be able to use filter like this. However, when we try to get the data from the parent table but not in child table, then we have to apply the filter condition on top of the primary key field in the child table. This will always yield us correct results. In this case, you can see that as part of filter, I have course enrollments dot course enrollment ID is null. Course enrollment ID in course enrollments is nothing but primary key field. Once we apply the filter, then we should be able to project whatever we are interested in. You can see the output here. We got all the user details. When it comes to course ID and course enrollment ID, they are nulls. If you want to get only user details, you can just say u.star. It will only project the user details. Now let's try to get number of courses enrolled by each user. If there are no enrollments, then count should be 0. If you try to use count on top of group by like this, on top of data frame which contain the join results, then you will see incorrect results. Even though users 1 to 6 are not enrolled for any courses, it will return 1 if you use this approach. Because even though we have nulls with respect to course enrollment details, still we are seeing one record. When we use count on top of group by, it will return 1 for those 3 users. You can see the output here. For user ID 1, it is 1. For user ID 2, it is 1. For user ID 6, it is 1. For rest, it is correct results. To address this, there might be multiple ways. However, one of the ways is to use when and sum. So when the course enrollment ID, which is nothing but primary key as part of course enrollments, is null, then I would like to assign 0. Otherwise, I would like to assign 1. I can add all those zeros and ones for each and every user, and I should be able to get the number of courses enrolled by each user. That is what we are doing here. This is the approach which we can leverage using ag and sum. I have imported sum as well as when. As part of sum, you can see the logic. This entire logic is part of sum. First, we are invoking when. As part of when, I am actually checking if the course enrollments df. Here I have to specify course enrollment ID. Even users ID will actually give us correct results, but sometimes it might give incorrect results. It is better always to use primary key in the child table rather than using any other field. Even this one will give us the same results. First, let's review the output. You can see that with respect to user ID 1, 2 and 6, we are seeing 0 now. But for rest of the users, we are seeing the actual count. Now, if you go to the logic, here we are comparing course enrollment ID with a null. If that is the case, we are assigning 0. Otherwise, we are assigning 1. So if it is not null, we are assigning 1. So all the zeros and ones will be added for each and every user, and we should be able to see the count as per the expectations. We can also pass the logic using SQL style syntax. If you wanted to use SQL style syntax as part of sum, you can actually import expr, and then you should be able to use expr as part of sum. As part of expr, you should be able to pass the logic using SQL style syntax. When it comes to SQL style syntax, we typically use case and when like this. So in this case, when course enrollment ID is null, we are assigning 0. Otherwise, we are assigning 1. Using those zeros and ones, we are able to get count for each and every user ID. Keep in mind that it is very important for you to understand how to perform downstream transformations on top of data frames that are created using join results. If you are not comfortable with it, then you will be struggling with respect to solving the problems both in certification exams but also as part of the real projects. That being said, This is how we should be able to perform outer join using left between Spark data frames. Keep in mind that just saying outer means full outer join, not left outer join. And also keep in mind that when it comes to left outer join, the driving data frame should be the data frame which contain the data from the parent table. Then join, then you have to pass the second data frame, which is typically driven by the child table as part of the source database. You need to keep in mind about the order, then only you will be able to come up with solutions effectively. As we have gone through the details related to performing outer join using left between Spark data frames in the previous lecture, now let's talk about performing outer join using right. Most of the concepts are same. Only thing is you need to observe some differences when it comes to outer join using left versus outer join using right. Based upon the side of the driving data frame, we have to specify whether left or right. In this case, as we are talking about right, you need to make sure that the driving data frame is passed as part of the function like this. The other data frame should be used to invoke join function. As the driving data frame is on the right side, we are using right here. However, there are few side effects which you need to keep in mind when you switch to right from left. If you look at the output, the details from the child data frame came first, followed by the details from the parent data frame. It is because we are using child data frame here. First we got the results from the child data frame, followed by results from the parent data frame. That is the major difference which you need to keep in mind. Rest of the stuff is same. You need to make sure that the aliases are used properly and you should be able to achieve whatever you are looking for. When you pass the join column as string like this, you can see that the join column is coming first. User ID actually is coming first. If you look at this output, in this case, user ID is not the first column. But here, when we actually use right and when we specify the common column between the two data frames as a string like this, it is actually projecting that field first, followed by the fields that are there from this data frame, then followed by the fields that are from this data frame. Whether we use left outer join or right outer join, any downstream transformations will look exactly the same. For example, in this case, we are projecting the data from the data frame that is created by this join. You can see it doesn't change whether we use left or right. It is same. Same is the case with filter. You can see the example related to filter and also the aggregation. So all the downstream transformations will remain same whether you use left outer join or right outer join. Only thing you need to keep in mind is based on the side of the data frame which actually drives the join, you have to use the left or right. If you are actually invoking join on top of driving data frame, then you have to use left. If you are passing the driving data frame as part of join call, then you have to use right. You have to keep that in mind. Also keep in mind that outer means full outer join. It is neither left outer join or right outer join. You need to make sure you remember that. As we have gone through the details related to performing left as well as the right outer join on top of Spark data frames, let's see the difference between the two. When it comes to left or right, it is nothing but the side. It is used based on the side of the driving data frame. Between users and course enrollments, users is typically the driving data frame as there is one-to-many relationship between users and course enrollments. Whatever side users is, we have to specify left or right based on that. Here is how we typically perform outer join between users and course enrollments, especially with respect to left or right. Users left outer join course enrollments or course enrollments right outer join users. Based on the side of the users, we typically specify left or right. Same is the case with courses and course enrollments. Between courses and course enrollments, courses is typically the driving data frame because we have one-to-many relationship between courses and course enrollments. For each course, there can be n number of enrollments and hence there is one-to-many relationship between courses and course enrollments. As courses is the driving data frame, based on the side of it, we have to specify left or right. Here is how we typically perform outer join between these two. Courses left outer join course enrollments because courses is on the left side, or course enrollments right outer join courses because courses is on the right side. We have to specify right. Keep these subtle differences in mind. Otherwise, whether it is left or right, conceptually both are same. Depending upon the driving data frame, we have to determine the side and we have to use correct syntax to take care of the join without getting into too many issues. As part of this lecture, let's go to the details related to performing full outer join between Spark data frames. In this case, we are creating two data frames by name users1_df and users2_df. The list that is used to create users1_df is nothing but this one. You can see here. The list that is used to create users2_df is nothing but this one. When it comes to the data, there is overlap between users1 and users2. However, there are few records which are part of users1_df but not part of users2_df. In the similar fashion, there are few records that are part of users2_df but not part of users1_df. You can review the count with respect to users1_df and users2_df. You can see that users1_df have 15 records, users2_df have 13 records. When it comes to syntax with respect to full outer join, you just have to specify the first data frame name dot join, then second data frame name, then the join condition. Join condition can be string, it can be column object like this, or it can be list of strings also. String or list of strings can be used when we want to use columns with the same names between the both data frames. In this case, we can also pass email as a string and it will work as per the expectations. When it comes to how, which is nothing but third argument, either you can specify full or outer or full outer or full_outer. Any of these strings will actually result in full outer join only. When we perform full outer join between two data frames, we'll get all those records which satisfies the join condition, and also those records which are there as part of the first data frame but not part of the second data frame, and also those records which are part of second data frame but not part of first data frame. You can review the results here. With respect to the first record, the record is part of users1_df, but there is no corresponding record as part of users2_df. That's why we are seeing nulls with respect to the columns that are related to the second data frame. Let me actually scroll up here to review the column names. Now you should be able to review the column names. So with respect to the second record, which I was referring earlier, you can see that we have data related to first data frame, but with respect to second data frame, all the columns have null values, which means this record is part of first data frame but not part of second data frame. However, if you review the first record here, you see we got values for all the columns related to first data frame, which are nothing but these ones, and also we are able to get the values related to all the columns in the second data frame, which are nothing but these ones. Because in this case, satisfying the join condition, we have data in both the data frames. That's why we are seeing the data like this. If you look at the third record, you are seeing nulls with respect to columns associated with the first data frame. However, with respect to second data frame, we are seeing the actual column values. It means this record belongs to second data frame but not first data frame. This is how the full outer join results will be. In place of full, we can also specify full outer or full_outer or even outer. Whether it is full outer, full_outer or outer, all these will yield the same results. You can actually review the output and you will find that the results are same. Here is another way of performing full outer join. Instead of passing condition as column object, we are passing column name. As both users1_df and users2_df have email column, it is actually performing full outer join based on that. One of the difference which you need to keep in mind when you perform full outer join like this instead of having condition is, if you look at the previous output, email is repeated twice. And also you can find nulls in this email as well as in this email. So for those records where the first data frame doesn't have values, you can see nulls in this email. For those records where second data frame doesn't have values, you can see nulls in this column email. However, when it comes to performing join like this, where the common column between the two data frames is passed as a string, it is not repeated twice. It is placed only once. As part of that, you don't see null values. So wherever email is, it will pick from that data frame and it will come up with the values in this column. For rest of the columns, whatever we have seen earlier applies. For example, for this record, there is no record in users1_df. That's why we are seeing null values. These are all related to users1_df columns. For this record, there is no record in users2_df. That's why you are seeing null values with respect to users2_df columns, first name, last name, gender, IP address, and so forth. Now you can actually get the count based on the full outer join. You can see that we got 20 records. When it comes to full outer join, it is same as left outer join, union right outer join. In this case, as we are talking about users1_df and users2_df, full outer join between users1_df and users2_df is nothing but users1_df, left outer join users2_df, union users1_df, right outer join users2_df. You can see here, this is the data frame which is based on the left outer join between users1_df and users2_df. This is the logic which actually get us the right outer join between users1_df and users2_df. Then on top of the data frame which is created because of the left outer join between the two data frames, we are invoking union, and then we are passing the data frame which is created because of the right outer join. If you look at the output, it is same as what we have seen earlier. However, you will find duplicates. You can actually review this. This record is repeated twice. If I scroll down, there is another record which says Andris Falconer. It is because the union which is there between these two data frames doesn't eliminate the duplicates. To make sure we get the similar results as full outer join, we need to use distinct on top of it. Now let's review the count with respect to this union operation. You can see it have returned 28. Now I have used distinct. The duplicates are eliminated. You can quickly review the count here. After distinct, if you apply count, it is actually returning 20. In this case, these results are same as full outer join between users1_df and users2_df on email. Now let's go to the details related to projecting the data after full outer join. In this case, we are going to get the details from the users1_df. If details are missing as part of users1_df, then we would like to get from users2_df. We are giving a bit higher priority to users1_df, and then we're actually getting the results from there. If something is missing, we are going to get from users2_df. For this, we should be able to use coalesce. When it comes to coalesce, it will actually return the first not null value from the arguments that are passed. You can see here, after joining users1_df and users2_df using full, we are actually using coalesce on email, first name, last name, gender, as well as IP address. First, we are actually referring email from users1_df as part of coalesce. Then we are saying users2_df of email, so and so forth. So in this case, if email is null as part of users1_df, then it will pick the email from users2_df. If it is not null, then it will pick the email from users1_df only. So it is giving higher priority to users1_df. So out of these two data frames, the important one should be here, and then we have to invoke join, and then we have to pass the second data frame. Now you can see that we got the data in the form of email, first name, last name, gender, IP address. The values came from the coalesce functions in this case. You can see the output. You can also achieve the similar functionality using aliases. So in this case, we are using alias. We have provided U1 as alias for users1_df and U2 as alias for users2_df. Instead of referring to columns using data frame names, we are actually using aliases. Other than that, the rest of the logic is same. You can see the output here. The output is as per the expectations. That being said, this is how we should be able to perform full outer join between Spark data frames. When we say outer with respect to how, it means full outer join only. On top of outer, we can also specify full outer join using full or full_outer or full outer. As part of this lecture, let's get an overview of broadcast join in Spark. Broadcast join is also known as map side join as well as replicated join. The other type of join is nothing but reduce side join. When we have two larger datasets and when we perform join, it typically uses reduce side join. When it comes to broadcast join, the smaller dataset which is less than 10 MB by default will be broadcasted to all the executors in the cluster. The default value with respect to size of the smaller dataset is driven by this property. It is nothing but spark.sql, then .auto broadcast join threshold. It is very important for you to remember this property name. It is nothing but spark.sql, then .auto broadcast join threshold. When the size of the smaller dataset is greater than the value that is specified in this property, it will use reduce side join. However, we should be able to perform broadcast join even when the smaller dataset size is greater than the value set using this property by using something called as broadcast function. Broadcast function is available as part of pyspark.sql.functions. We can also disable broadcast join by setting this property value to 0. If you set this value to 0, it means irrespective of the size of the smaller dataset, it uses reduce side join only. If broadcast join is disabled by setting this value to 0, then it will always use reduce side join. To actually execute this notebook, make sure to set up multi-node cluster using 28 GB memory, 4 cores each. You can also configure scaling between 2 and 4 nodes. Driver can be of minimum configuration. We need to set up the cluster using this configuration so that the broadcast function and also setting this value to much higher value can be evaluated. That being said, to set up the cluster, you can actually go to compute. You can give any name to the cluster, let's say broadcast join. You can choose the 9.1 LTS, it is fine. In this case, you can reduce it to 15 or 30 minutes, whatever is the desired value for you. Now you should be able to expand this. In this case, you choose 28 GB memory and 4 cores. This is the one which you can choose. I would like to give more memory to each core. In this case, you will get almost 7 GB for each core. When it comes to max workers, you can actually reduce it to 3 or 4. It is fine even to use 3. You can also check on spot instances. If spot instances are available, it will pick spot instances. If it uses spot instances, the cost might be lower. When it comes to driver type, instead of using same as worker, you should be able to choose the lowest configuration, which is nothing but 8 GB memory and 4 cores. Then you should be able to click on create cluster. It will take care of creating the cluster. Once the cluster is created, you should be able to attach the cluster to the notebook, and then you should be able to take it further. Now, if you look at the default value with respect to this property, it is nothing but 10 MB. You can see here, this is actually 10 MB. You should be able to disable using this piece of code, spark.com.set, then the property name, then 0. As you have set it to 0, it means broadcast join is disabled. You can reset it to original value by using this piece of code. Now the value for this property is nothing but 10 MB, which means only when the size of the smaller data frame is less than 10 MB, it will actually result in broadcast join. Otherwise, it will perform reduced site join. Now we are creating a data frame by name clickstream. In this case, this location have dataset of size 1 GB. It is actually more than 1 GB. The data is separated by tab, and also the data have header, and hence we are saying header equal to true. You can see that data frame is created as per the expectations. The data frame have columns such as previous ID, cur ID, and previous title, cur title, and type. This one is 10 GB dataset. This location contains Parquet files. And hence we are using spark.read.parquet to actually read the data from this location into the data frame by name articles. So we have two data frames. One is articles, second one is clickstream. Out of these two, clickstream is the smaller one. The size of clickstream is close to 1.2 GB. Now, as the size of the smaller data frame is greater than the value related to this property, it uses reduce site join. You should be able to review the explain plan of the logic here, and you should be able to confirm whether it have used reduce site join or not. You can see that there are 4 jobs associated with this join logic. You should be able to click on view with respect to any job here. It will actually load the UI for this job. It will take some time because the cluster is at this time terminated. Now you can see the details with respect to this job. You can also click on jobs to see all the jobs. You can see here, you can review all the jobs, but we are interested in this one. So we can click on view to go back to that. It is not actually refreshing. So let me close this. Let me click on view. Now you can see that you are in the stages related to this job. You can also go to the SQL. You should be able to see the SQL details for each and every join operation that is there as part of this notebook against this cluster called as broadcast join. You should be seeing these job IDs. You can see here the job IDs are nothing but 6, 7, 8, 9. You can see that the job IDs are nothing but 6, 7, 8, 9. Whatever you are seeing here is related to the jobs associated with this join logic. Now you should be able to click on this. It will actually take you to the visualization of the underlying execution plan. You can see here, it is actually reading data related to both the datasets, and then it is performing something called as sort merge join. Sort merge join is nothing but reduce site join. After the join, it is actually taking care of executing rest of the logic to get the count. If you review the code here, we are trying to get the count. In this case, by looking at the visualization of the generated plan, we are able to confirm that it is using reduce site join. Now, you should be able to use broadcast function like this. In this case, I'm saying broadcast of clickstream. Clickstream is the smaller dataset, which is of size 1.2 GB. I am broadcasting that while performing the join with articles. Now, you should be able to expand this. You can see that this logic is executed using 2 jobs versus 4 jobs. You can click on view. Then you should be able to go to SQL. The job IDs associated with this logic is nothing but 11 and 12, and hence we should be reviewing this. You can see 10, 11 and 12 here. So you should be able to click on this and you should be able to review the details. You can see that it is using broadcast hash join. Earlier it have used sort merge join when we do not use the broadcast function. Now it is using broadcast hash join. That being said, even though the size of the smaller dataset is much greater than the value that is set using this property, which is nothing but much greater than 10 MB, it still use broadcast join because of the broadcast function. You can achieve similar behavior by setting the property spark.sql.auto broadcast join threshold to 1500 MB like this, which is nothing but close to 1.5 GB. Once you set this property like this, then you should be able to say clickstream.join. You don't need to use broadcast function. It will actually take care of broadcasting the clickstream before performing the join. You should be able to achieve broadcast join using the same datasets by setting this property without using broadcast function as well. You can give a try and validate and see whether it is working as per the expectations or not. This is the quick overview of broadcast join in Spark. Make sure you are comfortable with the function called as broadcast. and also you are really comfortable with respect to this property spark.sql.auto broadcast join threshold. You might see 1 or 2 questions around broadcast join because it is very, very important. I have not covered all the key concepts with respect to broadcast join in this lecture. I primarily focused on the APIs and the properties related to broadcast join. I might cover the concepts related to broadcast if it is important as part of some other section where I'll be talking more about Spark architecture in general. As part of this lecture, let's go to the details related to performing cross-join using Spark Dataframes. First, you need to have Dataframes. All the 3 Dataframes are created. They are nothing but courses_df, users_df, and course_enrollments_df. Now, if you scroll down, you should be able to see the help related to cross-join that is available on top of Dataframe. Dataframes exposes a function called as cross-join. You can actually review the help related to cross-join. You invoke cross-join on top of one data frame and pass another data frame. It will result in Cartesian product between the 2 data frames. You can see the examples here. Also, you should be able to see the results here to understand the behavior with respect to cross-join. In this case, we are performing cross-join between users_df and courses_df. As part of users_df, we have 10 records. As part of courses_df, we have 5 records. But when it comes to the output, it have more than 20 records. You can actually perform count to see number of records with respect to cross-join. For these datasets, it have generated 50 records. The number of records that will be part of this new data frame because of the cross-join will be equal to number of records in first data frame multiplied by number of records in second data frame. In this case, users have 10, courses have 5. 10 times 5 is 50. That's why we are seeing 50. We can also use join. If you do not pass any condition, it will result in a Cartesian product or cross-join only. You can see the output here. You can also review the count. It have returned 50 records, which means cross-join or join without any additional arguments other than the second data frame mean same. You can also perform cross-join using join with how like this. As part of how, if you say cross, it will result in cross-join or Cartesian product only. You can see the count. Even this approach have resulted in 50 records. This is how you should be able to perform cross-join between Spark data frames. Either you can use direct function cross-join on top of data frame and pass another data frame to perform cross-join, or we can also use join function with only data frame as argument and also using how equal to cross in this manner. With respect to Databricks Certification Exam, make sure you are familiar about all the 3 styles while performing cross-join between 2 data frames. There might be 1 or 2 questions around it. The questions will be pretty straightforward. If you are familiar about all the 3 styles of syntaxes and also if you are familiar about the relationship between cross-join and Cartesian product, you might be able to answer those questions without making any mistakes.